Question 3 over here is on trigo proving, so-called in this context, and also on solving trigonometric equations. So without further ado, let's try question 3i. So given the function fx equals to 1 plus 2 sine square 3x plus 4 cosine square 3x, express fx in the form a plus b cosine 6. So for 3i over here, okay, we are required to express in this form. So let's try a few ways. Okay, here we know one identity, that is sine square x plus cosine square x equals to 1, right? So what I'm going to do is I'm going to bring the cosine square x over to the right hand side. So sine square x equals to 1 minus cosine square x. Okay, now I want you to remember this. Okay, we can write this equation. It is also true if we replace x with 3x. So sine square 3x equals to 1 minus cosine square 3x. This is perfectly fine, and the same goes for the formula sheet and your other trigo identities. You can do this type of replacement and the equation still holds true. So using this equation over here, I am going to substitute in here. So fx is equals to 1 plus 2 bracket 1 minus cosine square 3x plus 4 cosine square 3x. So this is actually equals to 3 plus 2 cosine square 3x. Okay, and we want to force this cosine 6x out. So there's another identity that is cosine cosine 2x is actually equals to 2 cosine square x minus 1. Okay, which means we have our cosine square 3x over here, right? So what I'm going to do, okay, I'm going to make this cosine square x the subject. Okay, so this is the identity given the formula. So cosine square x is actually 1 plus cosine 2x over 2. So what I'm going to do is I'm going to replace the x here with 3x, okay, so that I can get cosine square 3x. So x replaced with 3x, cosine square 3x equals to 1 plus cosine, because I replaced x with 3x, so 3x times 2 is 6x over 2, correct? So multiply the 2 over, so 2 cosine square 3x equals to 1 plus cosine 6x. So this means this is equals to 3 plus, substitute this one, I get 1 plus cosine 6x, which means that this is equals to 4 plus cosine 6x. And yeah, we are done, which is in the form of a plus b cosine 6x. So that's pretty much it for 3 part I. Now the idea when you do this type of question, right, is to try to usually play around with different types of trigo identities and see whether you can work your way up to what the question wants you to show. Okay, now sometimes if you are more proficient and you have a better intuition on how and which trigo identities that you should use, then generally you will be able to get the answer quickly. Otherwise, it is perfectly fine for you to struggle a little bit in this type of question. You just have to try to guess your way to what the question wants you to prove. But actually, you don't really have to blindly guess and use any trigo identities, because think about it this way. Okay, for sine square 3x, right, it seems obvious that you can use this identity over here. Okay, and once you have perform the substitution, you arrive at cosine square 3x over here, and then you take a look at the formula sheet and you realize that, oh, I have a cosine square x here so-called, and I think I can make use of this, and I see that there's a cosine 2x. It seems quite similar to cosine 6x, correct? So then that will be so-called the trigo identities that you should probably use. So let's move on to part 2. Hence, find the exact value of fx equals to 3.5 for x between 0 and pi over 2 radians inclusive. So for this question over here, okay, x is between 0 radian and pi over 2 radians inclusive. Now because over here, right, fx is 4 plus cosine 6x, because we are looking in terms of 6x. So for this inequality, remember to multiply everything by 6 so that we can see the range of values of 6x, which here in this case will be equals to will be between 0 radian and 3 pi radians inclusive. Okay, so now fx is equals to 3.5, which means that 4 plus cosine 6x equals to 3.5, which means that cosine 6x is equals to minus 1 over 2, and then the basic angle alpha equals to cosine inverse of 1 over 2. Remember, when you take the cosine inverse over here to find the basic angle, you must take the cosine inverse of the absolute value of minus 1 over 2, which is 1 over 2. So one way to remember is that whatever that goes in here has to be positive. Okay, because here it is minus 1 over 2, I'm going to write 1 over 2 over here. So this basic angle alpha is actually equals to pi over 3 radians, and based on this basic angle, we are able to deduce that 6x, which is my so-called my theta. Now because cosine 6x is negative, so it is in the second and the third quadrant, correct? So it is in the second and the third quadrant, and my basic angle here is pi over 3 radians, similarly over here as well. So then the first angle is actually pi minus pi over 3, and the second angle is actually pi plus pi over 3. Okay, so that gives me 6x equals to 2 pi over 3 and 4 pi over 3. But we can take one more angle because 6x is between 0 and 3 pi radians inclusive. So here to here, I will add one more period. That will be, I will add 2 pi to 2 pi over 3, right? So I will add 2 pi plus pi minus pi over 3. In this case, this gives us 2 pi is actually 6 pi, so it will be 8 pi over 3 after adding 2 pi over here. Okay, so now we reach 8 pi over 3 radians, right? Radians. Should we add 2 pi over here? Okay, let's just do it for the sake of understanding. So if I add 2 pi here, right, this actually gives me 2 pi is 10 pi over 3. Correct? Yes. But 10 pi over 3 is actually more than 3 pi radians. But because 6x is between 0 and 3 pi radians inclusive, so I don't do that. Okay, so these 3 angles over here in radians is enough. So this, now I'm just going to find x, because I am supposed to solve for fx equals to 3.5. Okay, so x, everything divide by 6, we get 2 pi over 18, 4 pi over 18, 8 pi over 18 radians. Now that simplifies to x equals to pi over 9 radians, 2 pi over 9 radians, and 4 pi over 9 radians. Okay, and yep, we are done. That will be for question number 3.